أنا أستاذ.
هلا هيكل. كيف الشباب؟
منيح.
Yeah. Okay, يلا let's start sequence. Because did you copy the last time notes?
لا والله أستاذ.
ليش هالكسل هيدا؟
كسل. أستاذ
كنت
كان عندي الشغل مال.
كنت لازم اقول لبيك امبارح ولا اختك. Okay. بس هيك just small revision. What did we take in this chapter? First, we took the definition of the sequence. You know what is a sequence? So a sequence.
هيدول عم نعمل ريفيو.
Review بس to continue. Yes. Okay. Quick revision.
Okay.
Un can be defined as a function of n, like un equal to n plus 3 is a function of n. We can calculate u0 by replacing n by 0. u10 we replace n by 10. A recurrent sequence is a relation between un plus 1 and un. Like here, we have u0 equal 1, un plus 1 equal un plus 3. We can calculate u1, we can calculate u2, we can calculate by replacing n by 0, we calculate u1. Replacing n by 1, we calculate u2, and etc. Sense of variation of a sequence. To know the sequence is increasing or decreasing, the most common method is to study the sign of un plus 1 minus un. We calculate the sign of un plus 1 minus un. If un plus 1 minus un is positive, then we say un is increasing. If un plus 1 minus un negative, we say un is decreasing. And if un plus 1 minus un equal to 0, we say that un is a constant sequence. This is the mostly used method, un plus 1 minus un. We took examples. Convergent sequence. A sequence is said to be convergent if the limit as n tends to plus infinity of un is equal to L, where L is a number belongs to the set R. If the limit un as n tends to plus infinity is equal to L, well L is a given number, then we say that un is convergent. If L is infinity, then we say the limit is divergent. Example, this sequence, limit as n tends to plus infinity, we take the limit of highest power over highest power, 2n over n, we get 2 over 5, so it is convergent. While this sequence tends to infinity as n tends to plus infinity, then un is divergent. Also, what did we take? We take mathematical induction. To prove a relation that depends on n is true, we have 3 steps. First step, we verify that this relation is true for the smallest value of n. So verify that this relation is true for the smallest value of n. We suppose the given relation is true, and we prove this relation is true for the n plus 1 term. This is mathematical induction. We prove that it is true for the first step, and we took examples. Now, arithmetic sequence. What did we take last time is about arithmetic and geometric sequence, and we take these rules. This is a summary. Have you written the summary, Shabab? Haikaz?
Yes.
Thomas, did you write?
هيدا السمري مش كاتب.
So we have arithmetic sequence and geometric sequence. To prove arithmetic sequence, we have to prove that un plus 1 minus un equals d. هيدا d is called the common difference. While بالgeometric un plus 1 over un equals r. R is called the common ratio, d is called the common difference. un equal u0 plus nd, or un equal uk plus n minus kd. Haida here, if the first term is u0, if the first term is, I don't know, uk. While بالgeometric, un equal u0 times r power n, and un equal uk times r power n minus k. قلنا هيدا not necessary last time. Sum of terms of arithmetic sequence هي number of terms into first term plus last term. هيدي not necessary. While بالgeometric, sum is first term times 1 minus r to the power number of terms over 1 minus r. هيدا last آخر شيء أخذنا geometric sequence. Now, new item is bounded sequence. Bounded sequence. Do you know what's bounded sequence? Okay, في عندنا شيء اسمه upper bound, في شيء عندنا اسمه lower bound. And we have bounded sequence. So let un be a numerical sequence. So un, a sequence un is bounded from above. A sequence un is bounded from above if there exists a real number m so that un is less than or equal to m for all n belongs to m. A sequence is said to be bounded from above by a real number m if un less than or equal to m for all n in the set of natural numbers. يعني إذا un is always less than m is called an upper bound of the sequence, and we say that the sequence is bounded from above by m. M is called an upper bound of the sequence. You understand the definition of upper bound? We'll take examples, by the way. A sequence un is bounded from above if there exists a real number m so that un less than or equal to m for all n belongs to n. M is called an upper bound. هلا العكس 2. A sequence un is bounded from below if there exists a real number m, small m, such that un greater than or equal to m for all natural numbers. فإذا un less than m is called an upper bound. If un less greater than m is called the lower bound of the sequence. M is called the lower bound of the sequence. A sequence un is said to be bounded if there exist two numbers m and m such that un is between m and m. If un is between m and m, then we say that un is bounded sequence. Can I skip this page?
Yes.
Hi, Kaz.
Yes.
Example. Please don't write, then you will write. Consider the sequence un equals 1 over n plus 1. I need to prove un is bounded above by 1. I need to prove un is bounded above by 1. To prove that un is bounded above by 1, I have to prove that un will be less than 1. Un will be less than or equal to 1 for every n. To prove that 1 is an upper bound, I have to prove every term of the sequence is less than 1. So un is bounded from above by 1. To prove this, I take the difference un minus 1. un is 1 over n plus 1 minus 1. Common denominator, LCM, we get minus n over n plus 1 less than 0. Means un minus 1 less than 0 means un less than 1 for every n. So 1 is an upper bound. Now to prove 0 is a lower bound, to prove that un greater than 0. If un greater than 0, then 0 is called a lower bound. To prove that un equal 1 over n plus 1, since n is a natural number, this ratio is positive. This ratio is positive for every n. Then un is bounded below by 0. Then un is between 0 and 1. So un is between 0 and 1. You can write
أستاذ 1 كيف لقينا un minus
هو بيكون قايل لك show that بيكون قايل لك هو prove that un is between هو بيقول show that un is between 0 and 1. So to prove that un less than 1, you take the difference because un minus 1.
Yes.
Can I skip to the next page?
1 second, please.
Yeah.
Done.
Now, properties of a convergent sequence.
استاذ هيدا one example بتقدر تعمل مرة تانية.
Okay. We have this sequence like crest un equal 1 over n plus 1. We have this sequence un equal 1 over n plus 1. We need to show this. Okay, Haikas, we need to show that un is between 0 and 1. So, to prove that un less than 1, I take the reference un minus 1. un minus 1 is 1 over n plus 1 minus 1. LCM we get minus n على n plus 1. لأن هي natural number يعني n plus 1 positive or minus n negative. So it is negative. So un minus 1 is negative, then un less than 1. So we prove that un less than 1. I need to prove that un is greater than 0. Un is greater than 0 since 1 over n plus 1 is greater than 0. So un is greater than 0. So un is bounded between 0 and 1.
Okay, thank you.
Properties of a convergent sequence. Properties of a convergent sequence. First property, every convergent sequence admits a unique limit. Our property, every convergent sequence admits a unique limit. Anyway, sequence only has one limit. Second one, when the sequence un converges to L, when the sequence un converges to L, then limit as n tends to plus infinity of un equal limit as n tends to plus infinity of un plus 1. Shall I explain this one how in un? For example, if you have un equal 1 over n, how much limit un as n tends to plus infinity?
0.
0. What is un plus 1?
كمان 0.
Is 1 over n plus 1. So limit as n tends to plus infinity of un plus 1 equals 0. So is a un plus 2 tends to 0 كمان. So whenever the sequence converges to L, then the limit as n tends to plus infinity of un equal limit as n tends to plus infinity of un plus 1. Third property. Every increasing sequence and bounded above and bounded above by a real number and bounded above by a real number A. So every increasing sequence, if the sequence is increasing and bounded above by a real number A, converges to a limit L. Every converging sequence and bounded above. كتير مهمة هذا البروبرتي. Every converging sequence and bounded above by A converges to a limit L with L less than or equal to A. Is a sequence increasing وعنده upper bound بيكون converges. By the same way, for property 4, every decreasing sequence and bounded below by a real number B, bounded below by a real number B, converges to a limit L with L greater than or equal to B. So is a sequence decreasing? If the sequence is decreasing and bounded below by a real number B, then it is converges to a limit L with L greater than or equal to B. This line, not necessary. This line is not necessary. Also, these two lines are not necessary. Did you finish this page? Properties 1, 2, 3, 4.
Yes.
Yeah.
Yes.
Now, properties by comparison. Properties by comparison. First property. If UN and VN are two sequences, if UN and VN are two sequences such that not necessary to such that UN greater than or equal to VN, if UN and VN are two numerical sequences such that UN greater than VN, if limit of VN tends to infinity, إذا VN صارت infinity, بصير UN أكبر من infinity means limit of UN is infinity. UN أكبر من VN. إذا VN صارت infinity UN أكبر من infinity means UN limit of UN is infinity. If UN tends to minus infinity, بصير VN less than minus infinity, less than or equal to minus infinity, then VN is equal to minus infinity.
هيدا لازم يصير minus infinity.
يا واحد.
Limit as n tends to.
لا ما فيناش نقول n tends to minus infinity يا توماس. لأنه ليش n هي natural number يا توماس. اوكي؟
اوكي.
استاذ هلا هون UN is greater than VN و VN عم تقول plus infinity.
إذا ال UN صار بلس، إذا ال VN صار بلس infinity،
Yes.
بصير ال UN أكبر من plus infinity means UN is plus infinity. ما في number greater than plus infinity. Now إذا صار هيدا minus infinity بصير ال VN less than minus infinity. ال VN less than minus infinity. ما في number less than minus infinity, so VN tends to minus infinity. Property 2. If UN and VN are two sequences, if the absolute value of UN minus L less than VN, if UN minus L less than VN، إذا صارت ال VN 0، إذا ال VN صارت 0 قديش بيطلع معنا ال UN؟ إذا ال UN minus L less than or equal to 0 قديش بيصير ال limit of UN؟
ما نكتب VN 0 نحط.
بلا بنكتب VN، عم بقول إذا ال VN tends to 0، عم بقول إذا VN tends to 0 as N tends to infinity، إذا ال VN tends to 0 as N tends to plus infinity، معناتها ال UN tends to L. ال UN tends to L.
يعني هون صار convergent sequence.
Yes.
فوق مش convergent.
Oh no, divergent. The last property in this chapter, UN, VN, and WN are three numerical sequences such that UN less than VN less than WN. If this limit becomes L, and if this limit becomes L, then what will be the limit of Vn as n tends to plus infinity? Is the Vn between L and L? What will be Vn? If Un approaches L, Wn approaches L, then Vn will approaches L. This we call it sandwich theorem.
ايوه
كده الدرس ما عنده معنى، هلا صار ساندويتش منيح.
هيدا اسمه sandwich theorem.
استاذ هتقول فلاش ستاندز تو يعني؟
هيدا tends to L. هاي الفلاش اللي tends to L tends to L.
استاذ فيك ترجع ورا؟ Done.
Okay, still we have the last example in this chapter. Okay, consider the sequence. Consider the sequence UN equal U0, UN defined by U0 equals 0, UN plus 1 equal 3 plus 2 UN على UN plus 4 for n greater than or equal 0. Greater than 0, not greater or equal. This should be greater than 0. Or equal, yeah. فيك تحطه or equal. Part 1. How to prove that U1 is between 0 and 1. How to prove that U1 is between 0 and 1. How to calculate U1? U1 equal how much? From where do we need to calculate U1? Boys, from where we calculate U1?
من حتى of 0 plus 1.
نحط محل N0. U0 plus
Yes.
1 يعني U1 equal 3 plus 2U0 over U0 plus 4. How much is U0? U0 is 0. We get 3 plus 0 over 0 plus 4 equal 3 على 4. So U1 is between 0 and 1. Now we need to calculate U2. U2, how to calculate U2?
حط بدل ال N1
U2 equal 3 plus 2U1 over 4 or U1 plus 4 equals 3 plus 2U1. How much 2U1? 2 into 3 على 4 into 3 على 4 plus 4 equal 18 over 19. So U2 is between 0 and 1.
كيف طلع 18 هيدا أستاذ؟
عمل له calculations. 3 times 4 12. 12 plus 6 18. 18 over 4. We take the LCM.
فينا نمحي 2 مع 4 بضل 3 over 2 ناخد LCM 2
Yes.
بيطلع 2 times 3 6 plus 3
بيطلع 9 over 2 يعني 18 over 4. Part 2. Show that UN is between 0 and 1. How to prove UN by 0 between 0 and 1? Part 2. By mathematical induction. Mathematical induction فيها 3 steps. أول step I have U1 or U0. I can say U1 is between 0 and 1. تاني she suppose UN is between 0 and 1. Suppose UN is between 0 and 1. Step 3, show that UN plus 1 Okay, how to prove UN plus 1 is between 0 and 1? First, let's prove that UN plus 1 less than or equal to 1. I take the difference. UN plus 1 minus 1 equal 3 plus 2 UN over UN plus 4 minus 1. If we take the LCM, UN plus 4 بيصير عندنا UN minus 1. What is the sign of this expression? Positive or negative? UN minus 1? هيدا will be negative. ليش negative؟ لأنه أنا معي UN.
لأنه UN between 1 and 0.
Okay, UN between 1 and 0. هيدا negative صار.
Greater.
So صار UN plus 1 minus 1 less than or equal to 0 means UN plus 1 greater than less than or equal to 1. كمان how to prove UN plus 1 is positive? I need to prove that UN plus 1 is positive. UN plus 1 and dash عنا إياه, we have UN plus 1. I need to prove this. UN plus 1 equal 3 plus 2 UN over UN plus 4. هيدا positive لأنه UN positive. Finally, so UN plus 1 is between 0 and 1.
هو بده UN.
By induction, Thomas, we have 3 steps. Our step, we prove that this is true for the smallest value of n. We suppose that the given relation, we suppose that UN is true. We have to prove that UN plus 1 is between 0 and 1. This is mathematical induction.
It says UN positive.
Yes, we suppose UN is between 0 and 1.